We're going on a really long journey.
Yeah.
One that goes all the way back to 1977.
Wow.
We're diving deep into the story of Voyager 2. And
That's right.
yeah, so Voyager 2, it launched on August 20th, 1977.
Yep.
But here's a little interesting thing.
Okay.
Voyager 1, its twin, actually launched 16 days later.
Oh, wow.
But because of, the way they were going to fly, they had different paths.
Right.
Voyager 1 actually got to Jupiter and Saturn first.
Okay.
So Voyager 2 took kind of a different route, maybe a slower, more deliberate path, and that allowed it to do something really special.
Yeah.
Something that Voyager 1 couldn't do.
Yeah. I mean, you think about a spacecraft launched in 1977, and it's still out there.
It's incredible.
It's unbelievable, and it's still talking to us.
I know.
It's amazing.
So this trajectory, right, for Voyager 2, it was really designed to kind of take advantage of this rare alignment
Yes.
of the outer planets.
Yeah. In the late 1970s,
Yeah.
all those outer planets were kind of lined up in a way that happens very rarely.
It does.
And so this was the birth of the, what they call the Grand Tour.
The Grand Tour.
This idea that you could send one spacecraft and it could hit all 4 of the outer planet.
All in one trip.
All in one trip, using the gravity of each one to send it on to the next one.
That's so smart.
Yeah, it's pretty brilliant.
Yeah, so this Grand Tour,
Yeah.
it wasn't always the Voyager program, was it?
No, so the original concept was way more, way grander.
Okay.
They were talking about multiple spacecraft.
Oh, wow.
But the budget, NASA's budget is never as big as they would like it to be.
Right, of course.
And so they scaled it back, and it became the Mariner Jupiter-Saturn project.
Yeah.
And they were going to have 2 probes, and those 2 probes were just going to do flybys of Jupiter and Saturn.
Okay.
But even then, they had this idea in the back of their mind that, if everything went well with the second probe, they might be able to send it on to Uranus and Neptune.
So that second probe became Voyager 2.
Yes.
So its initial mission was basically just Jupiter and Saturn.
That's right.
But with the option of going on to Uranus and Neptune.
Exactly. If everything went well, they had that flexibility.
So the success of Voyager 1 was really important for Voyager 2 to be able to do that.
That's right. Voyager 1 had a very specific target at Saturn, which was the moon Titan. Titan is the largest moon of Saturn, and they wanted to get a really good close look at it.
Yeah.
Now, Pioneer 11 had gone past Titan, but it was, it didn't get very close.
Right.
So they really wanted Voyager 1 to nail that Titan flyby.
Right.
And if there had been any problems with Voyager 1, then Voyager 2 would have been sent to Titan instead.
As a backup.
As a backup.
Okay.
But Voyager 1 succeeded beautifully.
Right.
So that meant that Voyager 2 was free to go on to Uranus and Neptune.
Wow. So Voyager 1 had to succeed for Voyager 2 to be able to become the only spacecraft
Yes.
to ever visit those 2 planets.
It's really quite amazing when you think about it.
It is.
It was meant to be a cost-saving measure.
Right.
Scaling it back to just 2 probes.
Right.
But it turned out to give them this incredible opportunity.
To see the whole outer solar system.
Yes, with 1 spacecraft.
That's so cool.
It's a testament to their clever planning.
Yeah, for sure. So the spacecraft itself, right?
Yes.
This is where the engineering it blows my mind.
It's phenomenal.
They built this thing at JPL, and they designed it to last, right?
Yes.
And to be able to talk to us.
Communicate,
yes.
Yeah.
Across these incredible distances.
Yeah. I mean, you think about the challenges.
Huge challenges.
Operating in space, billions of kilometers away from the sun.
Yeah. It's freezing out there.
It's incredibly cold. It's a vacuum.
Yeah.
And somehow it has to send us these incredibly faint signals back.
And we have to be able to hear them.
And we have to pick them up.
Yeah. So let's actually break down the spacecraft itself.
Okay.
So it's got 16 hydrazine thrusters.
Right.
And those are for maneuvering.
That's right, for little tiny adjustments.
Little tiny adjustments, yeah. And then it has a 3-axis stabilization system.
Right.
Which keeps it pointed in the right direction.
Keeps it oriented correctly, yeah.
It's got gyroscopes, so it knows, its orientation in space.
Yeah.
And then it's got this really clever navigation system.
Yes.
That uses the sun and Canopus.
Right.
Which is a star.
Yeah.
So it's literally like navigating by the stars.
It's incredible.
It's amazing. And so all that pointing right is essential for the 3.7-meter high-gain antenna.
That's right.
Which is the big dish, right?
The big dish that we all see in the pictures.
The big dish that allows it to communicate with us across billions of kilometers.
Yeah, via NASA's Deep Space Network. So, when it was at Jupiter, it could send us data at 115.2 kilobits per second.
That's pretty good.
Which is pretty respectable.
Yeah.
But as it got further away, that data rate just plummeted.
Because it's so far.
Yeah, it's like, imagine shouting across a vast canyon.
Right.
The further away you are, the fainter your voice gets.
It's like trying to download a photo from the edge of the solar system on dial-up.
Right. It's
Yeah.
unbelievable that we can even communicate with it at these distances.
I know. So they put a digital tape recorder on board,
That's right.
which could store like 64 megabytes of data.
Which doesn't sound like much these days, but
No, not at all.
back then that was a lot.
It was a huge amount.
And so that meant that it could record data when it couldn't talk to us.
Right.
Like when it was doing those flybys.
And then send it later when it could.
Yes, right.
And then we have to talk about the power source, right?
Yes.
Because this thing, it was powered by 3 radioisotope thermoelectric generators.
RTGs.
RTGs,
Yeah.
which are basically nuclear batteries.
That's right.
And they were fueled by plutonium oxide.
Yeah. So these things were designed to provide power for a very long time.
And they did. At launch, they were giving 470 watts of power.
That's a lot.
That's a lot. And so these RTGs,
Yes.
right, they were the key to this mission lasting so long.
Yes, they were expected to last until at least 2020.
Amazing.
And they've actually lasted longer than that.
Yeah, they've exceeded expectations, but they don't last forever.
No, the power output declines over time.
Right.
Roughly, it halves every 87.7 years.
Wow.
But still, that's a long time.
It is.
And it means that they provided this very stable energy source.
For decades.
For decades.
But as that power started to, decrease, they had to start turning off instruments.
Yes, to conserve power.
Right? So which ones have they turned off?
Well, so far they've turned off the plasma science instrument.
Okay.
That was back in October of 2024.
Yeah.
And then the low energy charged particle instrument is scheduled to be shut down this month,
Oh, wow.
in March of 2025.
Okay.
So gradually the spacecraft is going silent.
It's kind of sad in a way.
It is. It's like, saying goodbye to old friends.
But it had a good run.
It's had an incredible run.
Yeah. Okay, so the solid rocket motor, right?
Yes.
That was just for the initial push.
Just to get it going.
to get it out to Jupiter, and then
And then they jettisoned it.
they got rid of it.
It was gone.
And then for the fine-tuning and, controlling its orientation, it uses those little hydrazine thrusters.
Yes, the 16 little thruster.
So how much fuel did it launch with?
About 100 kilograms of hydrazine fuel.
Okay.
And they think that will last until about 2034.
So these thrusters are kind of like the steering wheel.
Yes, they're like the steering wheel and the gas pedal all in one. And they have 2 sets of thrusters for attitude control, which is great because it's redundant.
Okay, so if one set fails,
They can use the other set.
that's smart,
Yeah, they designed it with redundancy in mind.
which is good because it's a long way out there.
It is.
You can't just send a mechanic.
No, you can't. Exactly.
Okay, so this thing was built to travel.
Yeah,
It was built to communicate, but it was also built to see and measure.
that's right.
So let's talk about its toolkit, its scientific toolkit.
Okay, so it had 11 different scientific instruments.
11.
11.
Yeah.
Each one designed to investigate different aspects of the planets it was going to visit and the space in between.
Right, so it was built to travel.
Yes,
It was built to communicate, and it was built to observe and gather data.
to understand those distant worlds.
Yeah, so let's go through some of these instruments.
Okay.
So we've got the Imaging Science System, or ISS.
The cameras.
The cameras,
Yeah.
right? It's got 2 of them.
Yeah, a narrow angle and a wide angle.
Right, and they've got different filters so they can capture different wavelengths of light. Yes. But sadly, those have been disabled.
Yes, to save power.
Yeah,
But we got so many incredible images
we did.
from those cameras.
We really did. And then there's the Radio Science System, or RSS.
Yes, so they used the radio signals from the spacecraft itself
Really?
to study things like planetary atmospheres and ring systems.
So clever.
Yeah, it's a very clever way of doing science.
And that's also been turned off.
Yes, unfortunately.
Yeah. And then we've got IRIS.
The infrared, interferometer, spectrometer, and radiometer.
That's a mouthful.
It is a mouthful.
And that one was designed to look at the energy balance and atmospheric composition.
Yes, of these distant worlds.
So it was looking at temperatures and what the atmosphere was made of.
That's right.
And that's also been powered down.
It has.
Yeah. But some of them are still working,
Some of them are still going strong.
like the triaxial fluxgate magnetometer, or MAG.
Yes, MAG is still operational.
So this one was looking at magnetic fields.
Yes, so not just the magnetic fields of the planets, but also the solar wind, and now the interstellar magnetic field.
Wow.
because it's in interstellar space now.
So it's still giving us information about where it is
Yes.
and what it's flying through.
It's amazing.
It's amazing. And the plasma wave subsystem, or PWS, is also still working.
Yes, that's right.
And that one's measuring electron density and these wave-particle interactions.
Yes, in the very tenuous near vacuum of space.
So it's amazing to me that with such limited power, these two instruments are still going.
It really is a testament to the engineers who designed them.
It makes you wonder what those other instruments saw
Yes.
during all those years when they were active.
Yeah, like the plasma spectrometer, or PLS.
Yeah.
That one studied the plasma ions in the space around the planets.
Okay.
And the low energy charged particle instrument, or LECP.
Another long one.
Another mouthful, yes.
That one measured ions and electrons.
Yes, their energy and their direction.
And then there's the cosmic ray system, or CRS.
That one looked at cosmic rays, these very high energy particles that come from outside our solar system.
So it was looking at where they come from and how they behave.
Exactly.
Okay. And the Planetary Radio Astronomy Investigation, or PRA.
That one was essentially a radio receiver,
Okay.
listening for radio emissions from Jupiter and Saturn.
So it was like listening to the planets.
Yes, it was like listening to the planets.
That's so cool. And the photopolarimeter system, or PPS.
Yes, unfortunately that one had a problem early on in the mission.
Oh, no.
But it was designed to study the surfaces of planets and moons
Okay.
and how they reflect light.
And all of these instruments, they were working together
Yes.
to paint this picture of the outer solar system.
Yes, a very detailed picture.
So let's go back in time.
Okay.
Let's journey back to those planetary encounters.
All right.
So first stop, Jupiter, 1979.
Yes. The closest approach to Jupiter was on July 9th, 1979,
Wow.
and Voyager 2 came within 570,000 kilometers of the planet.
That's pretty close.
That's pretty close for a spacecraft.
Yeah, and the images are amazing, right?
Yeah. Oh, they're stunning.
They show the Great Red Spot in all its complexity.
Yes, and all the other storms.
All the other storms.
Yeah.
And it also confirmed Voyager 1's discovery of active volcanoes on Io.
Yes, it saw those volcanoes erupting.
Io is such a weird moon.
It's an incredible moon.
Yeah, it's crazy. And it even saw that the surface had changed
Yes, between the two Voyager encounters.
in just a few months.
Just a few months.
So these volcanoes are like resurfacing the moon.
Yes, they're constantly changing the landscape.
It's amazing. And then there's Europa.
Europa, the icy moon.
Voyager 1 saw these linear features.
Yes, these stripes across the surface.
Right. And everyone thought, oh, these must be cracks.
Cracks in the ice.
Yeah. Or maybe even, tectonic plates
The
moving.
tectonics.
Yeah, but then Voyager 2 got closer.
Yes, with better cameras.
Oh.
And it turned out that those features were very smooth.
They didn't have any height.
No, they were flat.
Like someone had drawn them on.
One scientist said it looked like they'd been drawn on with a felt marker.
Really?
Yeah,
So it was a puzzle.
it was a puzzle.
It just shows you that sometimes
Yeah.
when we look at things from far away,
Our first impressions can be wrong.
we don't always get it right.
Exactly. Science is about revising our understanding as we get more data.
Exactly. It's a process.
It's a process.
And Voyager 2 also found some new moons around Jupiter.
Yes, 3 new moons.
Okay, so what were their names?
Adrastea, Metis, and Thebe.
Adding to the collection.
Yes, Jupiter has a lot of moons.
It does. It has a whole entourage.
A whole entourage.
Okay, so after Jupiter,
Saturn.
Saturn, the ring planet.
Yes.
So when did it get there?
The closest approach to Saturn was on August 26th, 1981.
Okay.
And Voyager 2 got within about 101,000 kilometers of the planet.
And it used its radio link to study the atmosphere.
Yes, as it passed behind Saturn.
Clever.
Yeah, they could measure the temperature and pressure at different altitudes.
Oh, that's cool. And what did they find?
They found that the North Pole was cooler than the mid-latitudes.
Interesting. So there's this temperature difference.
Yeah, it was a bit of a surprise.
Yeah, and there was a problem, right?
Yes, after the Saturn flyby.
With the scan platform.
Yeah, the azimuth actuator.
What does that do?
That's the part that helps point the instruments.
Okay.
It's seized up.
Oh, no.
Yeah, just for a moment.
But that's all it takes.
That's all it takes.
To lose data.
And they lost some data.
That's
It
frustrating.
was very frustrating.
But they figured out what the problem was.
yes, they think it was a problem with the bearing
Okay.
and maybe some corrosion and some space debris.
So it got jammed.
It got jammed.
And they managed to fix it.
Well, they managed to partially fix it.
Partially.
Yeah, they sent commands from Earth.
Really?
And they were able to get it working again, but not perfectly.
Enough to continue the mission.
Enough to continue to Uranus.
Wow. That's incredible.
Yeah, the engineers are amazing.
They really are. So this is why Voyager 2 didn't go to Titan.
That's right.
They had to get to Uranus.
Yes, they couldn't risk messing up the trajectory.
So they had to prioritize.
They had to prioritize.
But it did see the spokes in Saturn's rings.
Yes, those were a mystery.
What are those?
They're these radial features in the B ring.
Okay.
And they appear and disappear.
That's weird.
It's very strange.
Do we know what causes them?
We still don't fully understand what causes them.
That's interesting. So, on to Uranus.
Yes.
1986.
Voyager 2 became the first spacecraft to ever visit Uranus.
And the only one so far.
And the only one so far.
When did it get there?
The closest approach was on January 24th, 1986.
Okay.
And it flew within 81,500 kilometers of the planet.
And it found a bunch of moons.
It did. It found 11 new moons.
Wow. Okay, tell me about them.
Okay, so there was Cordelia, Ophelia, Bianca, Cressida, Desdemona, Juliet, Portia, Rosalind, Belinda, Puck, and Perdita.
They named them after Shakespearean characters.
A lot of them, yes.
That's cool. So Uranus has a lot of moons.
It does.
It's got quite a family.
And they're all orbiting this planet that's tilted on its side.
Right. Uranus is famous for that.
Yes, it's tilted almost 90 degrees.
So it's like it's spinning on its side.
It's like it's rolling around the sun.
And Voyager 2 was able to study the atmosphere.
Yes.
And it figured out how long a day is on Uranus.
17 hours and 14 minutes.
Okay, so a day on Uranus is shorter than a day on Earth.
Yes, that's right.
Interesting. And what about the magnetic field?
The magnetic field was a big surprise.
Okay.
It's very strange.
In what way?
It's tilted,
Okay.
like the planet itself,
Okay.
but it's also offset from the center of the planet.
What? So it's not in the middle?
No, it's off to one side.
Wow, that's really strange.
It is, and it means that the magnetic field lines are all twisted.
Okay.
So they form this long corkscrew shape.
It's like a spiral.
Yes, like a spiral.
And Voyager 2 saw clouds, right?
Yes, it saw these faint bands of clouds.
Okay.
And a strange glow at the South Pole.
A glow?
Yes, it's called day glow.
What is that?
It's a type of ultraviolet light emission.
Okay.
And it's caused by the interaction of sunlight with the atmosphere. But you wouldn't be able to see it with your eyes.
It's invisible to us.
Yes.
And it detected lightning.
Yes, but not the kind of lightning we see on Earth.
Oh.
This is Uranian electrostatic discharges.
So it's like a different kind of lightning.
Yes, it's caused by the interaction of charged particles in the atmosphere.
Okay.
And you wouldn't be able to see it either.
So it's invisible lightning.
Invisible lightning.
That's wild. And then there's Miranda.
Miranda, one of the larger moons.
What's special about Miranda?
It's a very strange moon.
Okay.
It has these huge canyons.
Really?
Yes, and very varied terrain.
So it's been through a lot?
It looks like it's been shattered and put back together again.
Wow.
Yeah, maybe multiple times.
And Voyager 2 also found new rings around Uranus?
Yes, 2 new rings.
Okay.
But they're different from the rings of Saturn.
How are they different?
They're much fainter.
Okay.
And they're probably made of different material.
What do we think they're made of?
Probably rock and dust.
Okay.
Maybe from a shattered moon.
So these rings could be the remnants of a moon that got destroyed.
That's the theory.
That's fascinating. And recently,
Yes.
scientists have been looking at the old data from Voyager 2,
Yes.
and they found something new.
They found evidence of a plasmoid.
A plasmoid? What's that?
It's a magnetic bubble,
Okay.
and it was ejected from Uranus's atmosphere.
Wow. So even after all these years
Also learning new things.
from the old data,
It's amazing.
it is. And then the final planetary encounter,
Neptune.
1989.
Yes, the last of the giants.
The closest approach to Neptune happened on August 25th, 1989.
That's right.
And it got really close.
It did only 4,951 kilometers above the North Pole.
Wow, that's closer than some satellites orbit Earth.
It is.
So how did they get it so close?
They did a course correction back in 1987
Okay.
to make sure it would fly over the North Pole.
And why was that important?
Because they wanted to do a close flyby of Triton.
Triton is Neptune's largest moon.
Yes, so they had to sacrifice some of the spacecraft's speed relative to the sun.
To get that close flyby.
But it was worth it.
So it was a trade-off.
It was a trade-off.
But they got a lot of great data from Triton.
They did.
And they saw lightning on Neptune.
Yes, Neptunian electrostatic discharges.
Just like on Uranus.
Just like on Uranus.
And it also detected plasma waves.
Yes, these waves of charged particles.
And it found new rings.
Yes, rings that we didn't know existed before.
And new moons.
Yeah, 6 new moons.
Okay, what are their names?
Despina, Galatea, Larissa, Proteus, Naiad, and Thalassa.
So Neptune has a lot of moons, too.
It does.
And it saw the Great Dark Spot.
Yes, that was a very prominent feature.
What was that?
It was a giant storm.
Like the Great Red Spot on Jupiter.
Yes.
Similar.
Yes.
But it's gone now, right?
Yes, it disappeared.
When did that happen?
Well, the Hubble Space Telescope looked at Neptune a few years later,
Okay.
and the Great Dark Spot was gone.
So it was a temporary storm.
Yes.
Wow. So Voyager 2, it completed its grand tour. It saw all 4 giant planets.
An incredible achievement.
It is. And then it began its interstellar mission.
Yes, that was the next phase.
When did that officially start?
October 2nd, 1989.
Okay.
That's when it left the realm of the planets.
And it crossed the heliopause, right?
Yes.
That's the boundary between the sun's influence and interstellar space.
That's right.
And when did it cross that?
November 5th, 2018.
And it was a long way out.
It was 119.7 AU from the sun.
What does AU mean?
Astronomical unit.
Okay.
It's the average distance between the Earth and the sun.
Okay, so it was almost 120 times farther away from the sun than we are.
Yes.
That's incredible.
It's mind-boggling.
And it's giving us information about interstellar space.
Yes, direct measurements of the density and temperature of the interstellar plasma.
Wow. This is stuff we could only theorize about before.
Exactly.
We've never been able to measure it directly.
Until now.
Until Voyager.
Voyager 1 and Voyager 2.
Right. Voyager 1 crossed the heliopause first.
Yes, back in 2012.
Okay, so both Voyager spacecraft are now in interstellar space.
Yes, they're both out there exploring the vast unknown.
It's amazing. So we're still in contact with Voyager 2.
We are.
Through the Deep Space Network.
Yes.
And the big antenna in Australia plays a big role in that, right?
Yes. DSS 43.
That's the one.
That's the one that talks to Voyager 2.
And the interstellar mission has had some interesting events.
It has.
Like,
well, there was the observation of Nova V1974 Cygni.
Cool.
That was an ultraviolet light.
Okay.
And they tried to observe the impacts of Comet Shoemaker-Levy 9 with Jupiter.
Right, that was a big event.
It was a big event.
But Voyager 2 couldn't see it.
No, it wasn't in the right position.
Yeah.
And then there was a problem with the magnetometer heater.
Oh, no.
Yeah, back in 2006.
Was it serious?
Not too serious.
Okay.
They were able to work around it.
And it crossed the termination shock?
Yes.
That's where the solar wind slows down?
Yes, it slams into the interstellar medium.
And it crossed it closer to the sun than Voyager 1.
That's right.
So that tells us something about the shape of the heliosphere.
Yes, it's not perfectly spherical.
Yeah.
It's kind of squashed.
Interesting. And there was a data format problem.
Yes, back in 2010.
What happened?
A bit flipped.
A bit flipped.
Yeah, just one bit in the data stream.
And that caused problems.
It did.
Wow. So even a tiny little thing like that.
They have big consequences.
It can mess things up.
Yeah.
And there have been times when we lost contact.
Yes, with the Deep Space Network.
Right.
Sometimes for days or even weeks.
Really?
Yeah.
That must be nerve-wracking.
It is, but they always manage to get it back online.
They always figured it out.
They're very good at what they do.
They are. And there was this strange increase in density.
Yes, in 2020.
What happened?
They don't know?
They don't know.
No, it's a mystery.
So Voyager's still out there making discoveries.
Even after all these years.
It's incredible. And it overtook Pioneer 10, right?
Yes.
To become the second farthest spacecraft
That's right.
in July of 2023.
Pioneer 10 was the first spacecraft to leave the solar system.
Right.
But now Voyager 2 is farther.